Okay. Thank you, everybody, for joining us this morning. Wherever you are from all over the world, it's the morning time here in Nigeria. So I'm Bilikisu Olatunji. I'm the founder and co-organizer of the Abuja R User Group. Today, we're going to be looking at deploying machine learning models in R with Plumber. That means we're starting from forecasting to production. So we're going to go step by step through this process with Ridwan and Sulaiman this morning. So before we go deep into it, I would like to give a brief background into our local community here. So this is Abuja R User Group. We're based here in Nigeria, the Federal Capital Territory of the country. So we are a community that we're trying to support ourselves in the learning and the use of R. So we support ourselves with these kind of trainings every month and every other month. So we do invite speakers both from within our local community and outside the country as well. So it's a free environment where we all learn and share what we know about R and how to use it, both in the academics, in the industry, or as personal improve on learning that you've done, you can share with us here. So it's not limited to anybody. Anybody here can be a speaker, and that's how we all learn. So I have lots of people that are supporting the group. So there are so many names that I would want to kind of take that out for today. So, but I want to really appreciate everybody that has been supporting the organization, the group. We're really grateful for your support, and we hope that we're living up to meet your expectations as well. And we pray that you will be rewarded well. And thank you so much. We really appreciate you. So for everybody, all the participants that are joining us both from within the country and outside, we're grateful for your presence here as well. We thank you to Soul as well for your support, and we are really grateful because without you, the program would be boring and we wouldn't know how we are impacting people's lives. So thank you so much. So without taking much of our time, I would like to introduce the speaker for today. So he's Adejuma Ridwan Suleiman is one of the main people that are supporting this group. He's been part of us. He's not in Abuja, but he's in Gombe, but he's been a very, very key stakeholder that has been helping to keep the community together. So he's a biostatistician at the Federal Teaching Hospital, Gombe. He's a data scientist, very fast in R and Python. He's also a data science instructor on Udemy. There's a lot about Ridwan that I wouldn't be able to push in there, but he's somebody that is very, very down to earth, humble, friendly, and always welcoming to help. He's always there to help anytime. So I would really, really want to appreciate Ridwan's taking his time to join us today again. Thank you so much. So are you ready?
Yes, I'm ready. I hope everyone can hear me.
Yes, we can hear you. If you can make it a little bit louder, then we'll be
Okay.
good with that. Yeah.
Okay.
So thank you. So I will stop sharing, then you can go ahead.
Okay. So, good morning, everyone. My name is Adejuma Ridwan Suleiman. I'll be the one hosting today's webinar, which is on deploying machine learning models in R with Plumber. So most of the key things are going to get from this webinar. I'm very sure most of us that are in this webinar, for us to have engaged, for us to have have the will to attend this webinar, it means that we have either maybe built a machine learning model in the past and we have an interest on it, because once you say the word deployment, it's more or less like putting something that is abstract into practical or real world use. So I'm going to be talking about deploying machine learning models in R. So most of the times, most machine learning models are just deployed with Python, and there are a lot of frameworks for deploying machine learning models. But specifically, we are going to be talking of Plumber for R. Plumber is not the only library for deploying with R. There are also other ones that have come up, but it's more or less like the I will not say, okay, more or less like the Pioneer library, and it's more or less like the actively maintained with a lot of support, which you can actually use in production. So we are going to be looking into it. How can you use it to deploy a machine learning models? Once you have your model, how can you put it into real life? So first of all, I'm going to talk about an API. Because most of what we use on the web revolves around the word API, where you want to, like, just for example, now this Zoom that we are using currently now is more or less like an API. I'm going to be sending my voice and video, and something is going to happen in the background which none of us know about. So it's going to now pass it to you on the other end. So it's not just my voice going to the other end. And also we are recording this particular video, which means that this all what I'm saying now, all what you are seeing on the screen is going to go to Zoom's database or Zoom's cloud to go and save it there. So all of this happens as a result of API. So API stands for Application Programming Interface, and it's the way softwares talk to each other. So it's just the way of softwares talking between each other, various applications, various softwares, and it acts as a messenger between various clients. For example, the front-end application and the back-end. Back-end is where maybe machine learning models will happen. If you have used ChatGPT, for Chat, you are going to input your text. Once you input your text, ChatGPT has to process it, which is actually a large language model. So it's not as if it's just some magic that's happening behind. It's going to take it to the model itself, which is hosted by OpenAI, and it's going to process it and give you the output. So, and that API, an organization can also use it as a service to provide it to others, maybe for a fee. So that is where you can see others are using the API for other works that are beyond what their organization can do. So they can also put restriction on it to just to grant you limited access on what you can or you cannot do with that particular API. So we have various applications that we have. Most of them are usually what's API, and it's very important in machine learning model because most of the times you build your model as in raw file. If you go to places like Hugging Face models, you're going to be seeing most of those raw models. Some of them have size of going to gigabytes. So these models, the best way for you to talk with them or use it because of resource limitations is to maybe use them as an API. So why do we use APIs for ML models? First of all, we're trying to decouple the model training from the model serving. So we don't want to be joining the training of the model and the serving of the model, which means that we have built a model, for example, model 1.1, and we are going to be serving model 1.1 to users. So while we are working on model 1.2, users are still using model 1.1, and we're able to compare between those models. Another thing also, we can separate those two models. We can build, let's say, model 1.1A and model 1.1B. Both are still under the same model they're having. I can serve them to different users. So we are able to separate the training of the model from the serving of the model. This is very useful for you to be able to see how various machine learning model works in real life. And also we can integrate it with other applications too also. For example, now I've already given an example of, simplest example is just that of ChatGPT, OpenAI. You can see the web application, but the whole of the ChatGPT itself revolves around the large language model. So that's actually what is powering everything. Everything there is just what we are seeing, the client interface, the history, things like that. But the main thing is the machine learning or the large language model that is behind, that is doing everything. And you can see they give you options of different models. We have GPT-4o, we have GPT-4, we have 3.5. These are various models. You can see they give you access to these models, and pricing is even placed on the ones that are more powerful. So this is an example of also the decoupling I was mentioning earlier on. And also in a simple way too also, just like the example I'm going to be doing today, I'm going to be using a forecasting example. You can integrate it with various dashboards, maybe in-house dashboard. A marketing agency, for example, can have data on their Google ads. They can be able to predict their revenue or the cost they are going to be spending on ads. So they can use this in their dashboards from the model I've already trained on their data. They can also use this same model on also mobile applications. So you can see one model can serve various places. Just like also the OpenAI, we have both the web and also the mobile, and all these are powered by just a single API. So what is just changing is the client. And we can also what version and scale. Version and scale means that you can have various versions of this model once you upgrade or build it. You can Dockerize your model, which is mostly what's common now, because once you Dockerize, you run anywhere. So you don't need for the platform that you're trying to host on doesn't need to be tuning. They don't need to tune themselves to be able to provide support for you. A simple case example is this R. So most platforms don't support the hosting of R Plumber or R services. So the simplest way is just to Dockerize it. Once you Dockerize your application, you are able to run it in anywhere, whether it is AWS, whether it is Render, or whether it is Railway, any of the hosting platform you want. Once you, as far as they can support Docker, and almost most hosting platforms support Docker, you are able to deploy it. So you are not limited based on this service cannot handle the programming language you are using. So how does an API request look like? So if I'm going to send somebody a message now, that message is going to be taken by an API. If you send a message, it's going to be taken an API, and from that API is going to go to where it's going to deliver it. Either it's possible you can send something and you are expecting it back, or you can send something and it's going to go to the database. Like signing up or logging in, your information will go to the database. But sending somebody a message, you are going to be expecting a response from that particular message. Or the API can tell that the message has delivered. That's also another way in which that particular message is going to go. So we have the endpoint. This is the URL where the service lives. The endpoint can be different endpoints. I don't know. Let me see my browser. Look at this. Are you seeing my browser?
Yes.
Good. So this is an example of an endpoint from year to year. This is the URL. This is that of Zoom. This is that of the Zoom post attendee. So we usually call these query parameters. Path parameters. So there's both query and path parameters. We'll get to that. So this is just an example of an endpoint, anatomy of an API request, because inside my slide, this is what is going to be represented. So this is just a simple example of what you see. So anytime you go to a site now, you should just try and take notes of how the URL looks like. So most of the time, when you want to log into a site, you see login. When you have already logged into the site, you see your username or your name that is going to show in this place. So that is how the endpoint looks like. And we have what we call a get post. We have various verbs of API. So specifically, we are talking of REST API in this place. So let me make that clarification. We have other types of API like GraphQL, which is used by Facebook. But most of the time, the most common that you're going to be seeing is REST API. So REST API is what we are just talking about in this particular webinar. We are more or less focused on REST API. So it's REST API that has this particular anatomy that you are seeing. We have various verbs. We call them API verbs or methods. The most common are get, post, put, and we have delete. So you can use this acronym CRUD: create, read, update, and delete. So these are the four main operations that are usually done on the back end. So when you are trying to get an information from the name. When you post, you are trying to post an information, and put is more like update. So most of the times, post and put are usually used interchangeably, and we have delete when we want to delete. So these are the various methods. Then we have the headers. When you authenticate to a site that requires authentication, you need to put your headers. These headers can be access tokens or any other set of metadata that is inside that particular headers, because that API endpoint will not work without that particular header. Then we have the body. So your body, for example, now when you're trying to request information from ChatGPT, the body is going to be the message you are giving. Give me a 250 word story. That particular information is called the body. So that is what your API is going to carry to wherever it is going to deliver it into. So this is a request response cycle of an API. So first of all, we have the clients. These clients can either be you, the human, or it can actually be another software. This is the client. If you send message from a web application, then you are the client. If it is a software that is sending message, then it's also a client. So when you send input data, mostly is in JSON, then you are going to be sending it to the API server. So this is for a machine learning model. This request response cycle is more or less focused on a machine learning model. You send it to API server, and this API server is going to call the predict function on the machine learning model, wherever it is what's saved. So the machine learning model is now going to predict the information that it has already been provided with. It's now going to return it back to the API server, and it's going to return it back to the client. So when you send your input to ChatGPT, ChatGPT is going to process and generate it, and you're going to see it. So the interesting thing is that most of the times let's put it like this. This can even be multiple ways in such a way that some other operations can also happen before it even goes to the ML model, such as saving to database and things like that. Okay, so this is just more or less like an intro to the API, this slide. So I'm going to be going to the R environment now to just have a look on how it works. Has everyone seen my R environment? Hello, can everyone see my screen?
Yes.
Okay.
Yes.
Okay. If you want to create a Plumber file, I want to use the Plumber package to create an API, because that is mostly what is used for, to create an API for a machine learning model. And most of the times, another important thing about Plumber before I proceed is that sometimes some people also use it for statistical analysis. Sometimes they want to display an information in their web application. Python doesn't support most, there's some complex statistical analysis that Python doesn't support, even though it has support, maybe the library is even limited. So what some people do, if they want people to see it, maybe in a particular application, they will use this Plumber to create it, to do all the analysis in R, and they will send it to that particular application for it to display. So you can have an application that was already built on Python already. Then there's some particular parts that cannot be handled in that Python. This is where you just use R to create a small API, you host it, and it's going to be sending information to that particular application to display. If you want to create a Plumber file, it's very simple. So this is just my project repository for the webinar, and this is the Plumber file. But most of the times, this is the Plumber file. So that's where it's actually created. You just go to File, you go to New Project. So once you click on a New Project, it's taking time to load. Once you click on New Projects, you select your directory. If you have a version control, a Git repository, you use this. For new directory, we are going to go to this. So you have various options here. You are going to be seeing it here. New Plumber API project. So this is it. Then you select it. Then you give your directory your name and you create. So I'm not going to be creating it, but I'm just trying to show the procedures. So by default, okay, or let me just create it because I still want to show some information. Okay, let me see the name of this file. Okay, so browse documents and I think model. What did I name this? Deploying. Okay, so I'm going to be using this my folder. I'm going to call it sample API. I'm going to create it. So it's going to create it inside my project for me. Okay, so this is it. It's inside this is it, the folder, sample API. And these are what you get. You get a default Plumber file. So you can actually clean that file. This is just an example of a Plumber file when you create it. So you can see you get this, we call this R oxygen comments, this hash and star. So there are different kind of comments from your regular comments in R. So this is a skeleton API. Now look at this. We have API title. You want to give your API title. You write it here. You use this particular decorators. We call these decorators. So decorators are more or less like a way of they more or less also act like functions that take other functions. Let me just put it in that latent. So these are example of a decorator. So anything that you write here is not a comment, it's taking it as, and if you want to write your decorators, you need to give these R oxygen comments. So these are the parameters we are giving to this input. Now look at this get verb, get echo. We call this our path URL, what I just showed you earlier on. And this is a function that is under it. So what is it going to do? First of all, you need to provide a message to this function. When you provide a message to this function, it's not going to what? Return this particular message. The message is this. So this is what is going to what? Return. This is another one for histogram. So we call this at serializer. You use this when you are not returning a normal text. You want to return an image, a shiny widget, or maybe a file. You use this at serializer. There are lots. If you after the webinar, we'll share the documentation link to also for those that want to go and dive more. So you have to specify the file they are trying to expect. So this one is a plot. We're also trying to get a plot. That's why I think the get verb. So we are plotting a random histogram in this place. This is the code. And we have this also. So this is taking a path parameter. So we have what we call path parameter. We have query parameter. So path parameter are what you actually see on your paths. Query is those that you query. These ones now, they are serving as both paths and query parameters. So you give this value, you have to give this value for this endpoint to work. So that's why they're called parameters. And we are giving it in the sum endpoint. So you can see because we are trying to what? Post. We are using the post verb. Most of the times you can even use this without seeing much difference. But when you're trying to add something, you use the post or the put. When you're trying to get something, you use the what? The get. So more or less, even though we are creating something here, more or less we are giving it the value to calculate in this place. So if you want to run it here, you have this button by default. How it's going to detect there is just like a shiny application if you are running it where you see run app. For an API, you also see run API. So I can run it in my browser, I can run it in my window. So I'm going to run it in my window. Let me just run it in my browser. I'm going to be running it in the browser. Can everybody see my browser? Can everyone see my browser? Good.
Yes.
So we call this is by default. This is your local server. It has a lot of use. So if you are on your system, you use this to just be able to check through it. This is called an automatically generated docs by Swagger. So I don't know if anybody have heard of Postman. So Postman is usually used in production. You want to collaborate with others because this one you can't collaborate. It's just for only your local system. But it allows you to be able to see all your endpoints that you're creating. We created the first endpoint, which is echo. I want to we are expected to give a message. So I'm going to be clicking try it out. You can see our verb here, get. You can see our URL here, echo. So in this place, I'm going to say hi Plumber. So hi Plumber is what I'm trying to send. This is my query, and this is the string. It's actually a string type. So execute. So this is the response that we get. We call it the response body, hi Plumber. And this is the URL. Now, if you look at this URL carefully, you can see a question mark in this place. This is the same thing you see when you browse something on Google. you're going to see this. Then you now see something like, I think it should be query, then what you actually search for. So this is what we're actually trying to look for. So this is the message we sent, the query parameters echo. So these are URL. Let's go to use a question mark to indicate that, yes, this is a query parameter. This is the message Plumber that is trying to what? Pass. So then we have other informations. This is the 200. These are very important. These codes, they allow you to know if something goes wrong. 200 means it's successful. When you get 500, it means there is server error. So this is for the first endpoint. Then we have a histogram. This is for the histogram. So the histogram will not give you any value. If you check it, we are not giving any value for the histogram. So once we just click try it out and execute, this is our histogram that we are having. So once you just this is the histogram. So if you want to add any parameter, so because he doesn't have any parameter, you can see this is the URL. So this is the URL. This should actually work. Let me see. I don't know. I think if you put it on your browser. So this is it. When you run it on your browser, that's it. Why is it going? When you run it on your browser, this is what you have. So the same thing too. Also, those other ones too we did. If you should run it on your browser, you should also have that particular output. When you run it on your browser, you should have this output too also. So this is it. This message is Plumber. So that is, I think we are done with 2 of them now. Remain the last one, which is the sum. So this one, when you see this asterisk, it means is what's required, which means you must give this value before you can execute. I must give this value. So I'm going to just give 2 here. I'll give 3 here. I'm going to execute. And I get 5. This is my result output. Now look at it here. So you can see they are also what query parameters. A is equals to 2. You can see sum. These are URL here. A is equals to 2. This question mark has to follow when you are using a query parameters. It shows you that anything that comes after that is a query parameter. So A is equals to 2 and B is equals to 3. When you also run it on your browser, oh, I think we are having error here. Okay, I don't know what the issue is. It is returning a 405 error. So more times that's the issue of running some of these URLs on the browser. A lot of times you can encounter some of these issues. So that's why this place gives you opportunity to be able to see how it works. So once you're able to see how your model API works in this place, then you can now maybe take it to your server to host it, and you now start using those endpoints, because anything you see here, any output you see here is what you are going to be getting from that particular application you want to use it in. So this is just it for the boilerplate, the sample Plumber API code. So let's go to our model API. So this is plumber.r. This is our model API that we're going to be building. So it's not something complicated. It's just something simple, just to give a grasp of all. So anything you can see here, you can extend on it to apply. There is a lot of things revolving around the plumber, but mostly if someone is able to understand the basics, then one could proceed from just that particular foundation. So I'm going to be using this data set. This is the Bitcoin data set. So let me just run this. I think I have a plumber file running. She should cancel. Okay. Okay. Mm. Okay, it's not going to run. I think I know why. Sure run. I'm just trying to view this file. Okay, let me just try this. It's large. So let us just view it here. I just want us to see how the file looks like. So the thing is that because we're in a Plumber directory, that's why it's mostly not likely to load on our console. So at least we can just see the file in this place. And this is our timestamp. This is our date. This is the date. This is the prices of Bitcoin, opening prices of Bitcoin. The opening prices. We have high, low, close, and volume. So all these are financial data. But mostly I'm just interested. I think I used the opening. So I think that's what we're interested. I think, was it the opening I used or the close? I think did I use the okay, we use the close. It was the close we used. So we're going to be using the close, and this is our date. So these are just the two important columns that we are needing. So these are for various because I'm seeing this for various times in the day. So I think we have the beginning of the day, the end. The beginning should be the timing. So we just have three of these values for each day. If you can see it, three of these values for each day. So well, I want us to be seeing how this actually works, but because we are using a Plumber file, that's the problem. We cannot just run it like a normal R file. So I'll just be explaining the code. So since most of us should be familiar with some of these tidyverse functions already. And so this one, we're loading the file. Just okay, I'm hearing you.
Okay. Someone is requesting for the data file. Is it data file or what? So what I would suggest is this. Can we just hold on? Okay. Maybe is it possible to share the data file? Because the code is working on the code. This is a live session. So things might change. So I would advise that if you get the data file, we might not be able to share the code because things are changing. So let's just concentrate on focusing on the explanation. So, but is it possible to share the data file?
Yes, I have a GitHub repository. I'll share the link so anybody that is interested in everything can just get it there.
Exactly. Please just share that, then you can move on. Thank you.
Okay. Can I continue?
Yes, yes.
Okay. Okay. Okay, let me do something here. I think because I just want us to be able to see the way all of these are working. Because some of us might just be new with this tidyverse. So I'm just going to just create it. Okay. So I think with this R markdown folder should work. I just pray so. Let me see. I think it's working. Okay, so we'll just use this markdown file to explain most of this. These are just the tidyverse parts. So there's not much things involved. So first of all, we read our data. It's actually a little bit heavy. It's 49.5 MB. So, and this is our so I've already showed the head of the data already. So it's just more or less like what the data consists of. So we're going to be using the closing. So I'm not that familiar about financial terminologies, but I think the closing price, maybe from my understanding, should be the final amount of that particular Bitcoin for that day. So then we want to ensure the date column. So now we're going to be using Prophet, which is the Facebook library for time series analysis. So this also, there's a lot of, if you check the documentation, there's a lot of things you could see on this Prophet. So this is just the simplest application of Facebook Prophet. So the Facebook Prophet always wants the dates of the data to be in date time formats. And this is from the Lubridates library, MDYHM. So when you have a date with time, because if you look at our data, it has date and time. This is it. So MDYHM is going to convert that date time to this format: month, then day, then year, then hours, then minutes. So then we are going to give our Bitcoin data. So this is for this. If we should run this now, and we check our head Bitcoin, so you can see our new, we have already converted the date. So we just changed that particular date to this new format. Then we want to extract only the day part, because now I'm just interested in only the day, not the timing. So I'm going to be using this floor date. It's going to ignore time and keep only dates of that particular date, and it's for what? Day, because the unit is what? Daily. So this is what we're going to be using to change that particular date. To change that particular date. So this is the date here. You can see the timing has gone, unlike before that we had those particular timing. Now, we want to now calculate daily average of the close prices. So we're going to be grouping by dates, because you can see some of these dates are similar. So we're going to group by those dates and calculate the average closing price. So we're going to be running that. And so you're not familiar with the tidyverse. This is just group by, it's going to group the dates and it's going to summarize. That is for each particular day. So it's going to calculate the average. So when you look at the daily data now, so you can see these are daily data, the closing price, and this is the date. So it's already summarized based on closing price and the date. And you can see it's even automatically post. You can see we have that this data is almost scattered. It's now starting from 2020. It's already automatically arranged. Now, if you want to prepare your data for Prophet, your column that is date has to be, the name of the column for the date has to be DS, while the name of the column for the price has to be Y. So once you do that, then you already have your data frame ready for you to use it with the Prophet library. So if I should call add Prophet now, so you can see this is more or less like, if you look at this Prophet, okay, sorry, it's supposed to be Prophet data. Okay, so this is it, DS and Y. This is the data frame. So this is the data frame, DS and Y. Y is more or less like what we are trying to predict, closing prices. This is DS for each day, average closing prices. Then we now train our model. So we're going to be training this particular model. So once we train the model, we have what we can use to predict. In real life, most of those models are very heavy. This one is because we're just doing something simple. This is it. So you can see all what this model is containing. These are all the information it's having. But most of the times in real life, we save it to what we call a pico file. Sometimes you use a job file. So these files are a way of squeezing the model into smaller sizes, because you cannot be running every time you're calling your application, you'll be running this. Because based on the way I wrote this example, anytime the application is called, this is going to be run. But I just did it like that just to simplify things. But one of the times you create a pickle file, is that pickle file that anytime your application is running, is going to be calling that pickle file. So that's where your model weights are being stored. Most of the times, if you go to Hugging Face models, where there are a lot of machine learning models and large language models, you see some, you can actually download those models in their raw formats. So you can see some of the sizes of those models. So that's their raw models, and that's where the weights are usually stored. So anytime a new model is created, those weights will change. Those new weights are what is now going to be used. So in production, you want to actually save this to a file, and once you save it to a file, it's going to be calling from that file. So you have a separate file where you train. So that's what I was telling, that we decouple the training and the serving. So you can't put this inside your API when you are trying to, because anytime the API is being called, this is going to be running. This particular thing is going to be running. And most of the times, it can actually, even when plenty people are running, it can crash your server. So most of the times, you just have to have that particular file. Okay. So that's it for building our Prophet model. Is just as simple as that. So I'm not going to dive much deep into Prophet today. And we are going to create our endpoint. So the endpoint is going to be taking the parameter date, because we want to know the closing price, the future closing price of for a particular date of Bitcoin. So we are going to specify our parameter, and you have to name this is very important. This R oxygen comment here allows you to be able to give your title to your endpoint, and you give your date. So all these things that are seen here are not comments. They are things that are going to be seen when you run your API documentation. So this is the date you are going to be providing. It's taking only a single parameter, which is date. Once you provide your date and you run your model, you should be able to get the model a future date. So this is the format, the month, and this is the day that is going to be taken. So the reason why I'm putting it here, so that anybody that is going to be using it is going to be knowing that, it's going to know that that's why it's called an API documentation. This is the format that we're trying to expect in this endpoint. Anything other than this, it will result in an error. And this is our parameter. Then we have our get method. Then we have the function, which takes most of what we are going to be running. So most of this function, I will not be able to I'll not be able to be running it the way I run it on the console. So I might just need to explain it, because they're actually dependent on the input that's given by that parameter. So, okay, well, like I just use an example. I think we already have model already. So I think we should be able to still use it here. So this is the input date, which is year, month, and day. So any date that is provided in this API is going to be put inside this particular YMD function. So this YMD function converts that input to a date object. It's not in a date object when it was given. So it's going to convert it to a date object. So if I have, this is YMD, if I have 2025 07 and 31st. Okay. Okay, it's supposed to be a string. It's supposed to be a string. So this is it. So this and these are two different things. This one is just a normal regular string. Why this they are looking at is a date object created by the YMD function from LibreDate. Then we get the last available date in the data set. So we're trying to get the last available date inside that particular data set. That is outside our machine learning, the data we use to train our model on top. I'm going to explain the reason why we need this, which is last date. So the last date you can see is 2021 4/20. Now, we have to validate the input dates. So if somebody doesn't give a format that is good, proper, we have to tell the person that the format is wrong. You should give another person format. So that's why I see there's this conditional statement here. So if the input date is missing, then you should return invalid date formats. Please provide the date in this format. If nothing was given, so we are making it compulsory to provide a value there. This is another conditional statement now. That is why I created this last date. So that if somebody gives a date, that is what less than or equals to our last date, because that person is not trying to predict the future, is trying to use something we already have on the data. So we return a statement to the person to provide a future date beyond the last available date in the data set. This is another way of validating. So I've already done that, and if all of these are to pass for that particular parameter that was provided, then we can now continue and proceed. We calculate the number of days to forecast. So that last date is also important to calculate the number of days to forecast. Input date, which is the date that was provided. Let's say I provide December 12th. December. Okay, let's say I provide December 1st, 2025, which is then the last date there was this. So it's going to calculate the difference between this and that to get the number of days to forecast, because we need that number of days to forecast in our model to predict. So if the number of days to forecast also is valid, if this is also negative, because a scenario can happen whereby we can get a negative value, because it's possible that okay, let me put it like this. Okay, it's possible that we can give a value such a way that we're going to be getting the difference might be negative or 0. So we have to also validate that, and it's going to, this particular conditional statement is going to return that the calculated forecast period is negative. Please check your inputs. So all this is just trying to make sure that the person is not giving any input. Most of this validation that I see is very, very important, because at times they use this to actually attack somebody models or get information from models. Like now, a model can be trained on private data to provide public information. Somebody can use that particular input to get what is not supposed to get, or to trick the model into giving some output. So a lot of times, most of these validations are very, very important. So after all of this, then we have a function to generate future predictions. So we have this make future data frame, which is from Prophet. It's going to make a future data frame from that particular date input that was given. It's going to take the model as an parameter, because it needs the model to predict or to forecast. Then we have the periods, which is the number of days to forecast. After it does that, then we are going to now what? Forecast the model future. So it's just like saying our model here now. We could just see, I just put it here, and I'm just going to make these periods to be 20. So this is the future data frame. This is prediction for 20 days ahead. This is the forecast for 20 days ahead. So then we have predict model future. So we're going to now predict the model future. Now we want to find the prediction for the input part date, because the person that gave the date is not interested in the data frame. He's interested in getting the closing price for that date. So we're going to use our forecast function, forecast variable, which is this particular model on the future data frame. Because I already created the future data frame based on the periods between the last date of the data set and the input date. Since we already have a future data frame on that, so I'm just trying to more or less trying to filter that data frame for that exact date. So I'm going to call the forecast, which is our data frame here, and I'll pass the filter function where ds equals to what the input date that was provided. Then that particular value usually returns a lot of column, but we're interested in the what? The dates. You should select only the dates column, and the y hat, which is the predicted closing price. This is the lower boundary for the predicted closing price and the upper boundary for the predicted closing price. So which means that even though this information is not accurate, then the model is sure that the values of the closing price of Bitcoin for that day is between these particular two values. So that's why I'm including it here. Then we're now going to return the prediction for that particular given date. So now this is a condition now also to return the prediction for the given date. So if the number of rows for the forecast for the day is equals to 0, there is going to return this particular, that is, if this data frame is 0. Okay, sorry, it's for this forecast date. If we should have, if for example now a particular year that was given succeeded in being validated, that is, it passed the previous validations we gave. But when we filtering it, we found out that the data frame is having 0 rows. Then it should be return this particular error that's unable to generate forecast for the given date. Please try a valid future dates. But if it is not this case, then it should just return this particular forecast for date. So we might still not need this, but this is also another validation just to make sure that even though the number of rows is empty, we are able to return something to the client that is seeing it. So if it's not so, if all of this is okay, we actually get a data after filtering, then it's going to return the forecast for date. So this is it for building the API. So I'm going to run the API now. Click on Run API. So it's going to take a little bit of time because of this particular model. So this is the URL here. This is our endpoint. This is just one. We created just one endpoint, and I'm going to try it out. 2025 month is going to be 12 and day is going to be 1st. We're going to execute this. Okay, so this is our output. You can see for the day, this is the closing price, and this is the lower and the upper boundary of this particular date. So if I'm to get, for example, now just give something that doesn't. Can you see the validation we gave earlier on? Invalid date format. Please provide a date in year, month, date format. So this is how those particular validations were implemented looks like. If I should give you a number also. So you can see it's giving wrong format. If I should also give something that was early, so let me see 2020 07 07. So this is another validation we implemented earlier on. Please provide a future date beyond the last available date in the dataset. So this is the last available date inside that particular dataset. So this is it about the Plumber API. So there's more to this, but most of the time we can find a lot of this in documentation. Then about the deployment, there are various ways you can deploy. You can use POSIT Connect, but I don't think POSIT Connect is actually have a free. I think it's paid. POSIT Connect is paid, so you can use POSIT Connect to. Is it POSIT? I think yes, it's POSIT Connect. Then you can use, but mostly what people even use is Docker. So they Dockerize the Plumber application and take it to maybe AWS or maybe Render or maybe Railway. So a lot of people, a few people actually use the default way of deploying, or how will I put it, putting into production. That is the Plumber API. Because now I've already built it now. The only thing that is just left is to just put it on the server and make it possible to the public. So that is where I'm now going to be maybe getting a proper URL. I'm not going to be using this URL because it's more or less like your local host URL. So this URL that you're seeing is more or less like what is on the local host. You're not going to be using that. So we are going to create more or less like buy a host for it and use it. So once it's in that your application, you're now going to be calling that particular end point. This can be as much as you want, depending on the kind of application you are building. So you can have various models for this. So depending on that particular application that you're trying to build. So there's also a counterpart that's for this for Python. We call it Fast API. That's also used for building APIs. There are also other libraries for building Plumber, for building API applications in R. So there are some of them are more like an improvement on Plumber because at times it can be slow. So there are some that are actually been built. A lot, I think I know about three, though I've forgotten their names. They also build on they also revolve around building APIs using R. So if you're interested in putting your API into production, the easiest way is to go through Docker. So, Bo, I excluded it out of this webinar because it's also it's something that should stand also as a topic on its own, because some people are not even familiar with the Docker interface at all. So you need to have your Docker. You need to you need to Dockerize it inside your application. So a lot of things are also involved in it. But I think in the future, I'm also going to be considering taking it as also as a webinar, how you can Dockerize your Shiny application. Once you have your Docker, you can run it anywhere that you want. So we are not going to have any issue. Just have to just pull that your Docker, just pull it from your Docker registry. That's your application. You can run it in any place that you want. So I think this is it for the webinar. I don't know if we have any questions. Are there any questions? I'm coming, sorry, before I proceed.
Okay, thank you.
Okay,
Okay.
please, a second, please. I want to
Okay,
go to
good.
I want to go to the documentation. There is a particular page. Okay, please, somebody's trying to. What's wrong with this? Why is it bouncing? Somebody's trying to make a comment.
Yes, we're waiting for you. Please, we want you to round up.
Okay. Okay, this is the
Or do
hosting.
you want us to go with the course?
Yes, I just want to show this is the hosting section. So these are the various ways. These are Posit Connect. So Posit Connect, I don't think is free. That's why you can't even use it to even try on it. So I think you have to pay. It's an enterprise. So you can use Digital Ocean. Digital Ocean is around, I think you can get it for around, is it $3 per month to host? You can use Docker also. This one is to take it directly on, because there's a way Digital Ocean supports Plumber direct without even using to use Docker. Then we have that of Docker, which is recommended, should be the best that you should follow. So, and we have for advanced. So we have multiple Plumber applications that talk to each other. So this is also an advanced part of the Plumber. So just to build on what we have already learned in this webinar, one can go through the documentation and go through it. So I think that's all.
Okay, I think we'll go with Harun first. He raised up his hands earlier. So Harun, do you want to speak or you want?
Yes, I would like to speak. Can you hear me?
Okay,
Yes,
go.
I'm hearing.
Yes, good morning. Thank you very much for this wonderful presentation. So I just want to quickly ask the Plumber library or package, which machine learning model exactly does it run? Is it possible we run models such as maybe random forest, linear logistic regression, and so with it? And that's my first question. Then the second question is why you were running it. realized there was no data splitting for the machine model. Is it possible we maybe split the data, maybe 80-20 for training and also for testing? That's the second question. Then my third question is, what if we have multiple parameters that we are trying to use to predict? Because you only use the close date. But what if we want to use maybe like 2 or 3 parameters to predict? So how do we go about that? Thank you very much.
Okay. Okay. Okay, so let me go back to the file. So you can actually, first of all, for your first question, you can use any model. So the the webinar, I just gave that as a sample model because we are more or less focused on the Plumber aspect itself. So it's even beyond just using it for the machine learning model. You can even use it to run. I saw somebody actually use it for a backend as an application. So backend of an application doesn't even use any machine learning model. The person actually using it to run the backend and send information to the database and things like that. So you can use any model you want to use with it. Just make sure that in production, most of the times it's even your pickle file that determines. So if you have that particular pickle file or job lib file, you use it. And I said you cannot be calling your model every time inside this particular API endpoint. So because of it's more or less like an example I'm trying to give. That's why I just use this particular data. And because time series is a very simple example I could give. If I'm to use something as regression, I'm going to be spending a lot of time on explaining the inputs, things like that. So I just use time series whereby I just give a single input and you get your output. And that's for a second question, which says that can you use, I think your second question was more or less like on multiple parameters, right?
The second one is on data splitting.
Okay, it's data splitting. Sorry.
Yes,
Data
exactly.
splitting. Yes,
Yes.
data splitting. Yes, for data splitting, it's true. We're supposed to split the data, but I thought that it's just an example. So I was trying to, because most of these things take time. So the training of the model, all those kind of things, we train it and things like that. So you normally are supposed to train your model. Your model that are even going to be supposed to be your trained model, not your test model. So after that particular trained model is what we are going to be using. So as you're looking at this example now, I want you to assume that we are using a trained model, which is on what? A particular piece of the data. So most of this particular, some of this machine learning parts of splitting the data into various things, I skipped it inside this particular example just to try and keep it simple as possible and not to divert away from the main topic. So you are supposed to split your data. Once you split your data and you train your model, you just assume it to be this model that we used and you use it inside your end point. Most of the times, the file I'm talking about is also works like this, that pickle file. Once you load it into, for example, R, then you call that particular file. That's where you load the file. Or you can even save it as an R object. Once you save it as an R object, you can use that particular R object to store it as a file. R object is also another thing you can use. You save it as an R object. Once you call that R object, it's not going to predict for you because it's already stored all the weights and everything that you need inside. And for the third is multiple parameters. Adding parameter is very simple. For this now, I can just, once I click on enter, I can just say add param. So let's say, let me just give something as, I think opening. I think I saw some columns there as opening. And I can say add param. Let me give something as mid. So this is it. So here is going to be the title of your parameter. Anything that you type here is going to be your title of parameter that you want. So you can just give it open and we can just give it mid. So we should run this. Okay. I think, did I save it? I think I'm supposed to save it. What's happening? Okay, let me do something. Let me. Okay. It's because I've not given it here. Open and meet. So okay. What am I pressing? Press this. So this is actually a publish button that you can use to publish to sit on it. What's happening? Okay, let me just stop it and see. Okay, so can everyone see it now? So this is the dates. Can you see it now? Okay, Aaron that asked the
Yes.
question. Is he saying it? Okay, so the dates, the open and the meet. So these are the two additional parameters I give. So it's just like what you do when you create a function. So we're going to give it at the top here. Then you have to put it also inside your function because those are the values that your function is going to be taking. So you need to give them at the top, and you also want to give them inside this particular function that you are trying to use. So this is how you can put multiple parameters, because you can have a regression model where you can be using 5. So this is how you can lay them out. You can use lay all of them out here and you put them inside this particular place. So I think, does that answer all your questions? Okay.
Harun, has your question been answered?
Yes, it has been answered. Thank you very much.
Okay.
Thank you. Okay, please, Babatunde, please hold on a little bit. Let me just answer. There are some questions here in the chat that had come earlier, even before Harun's. Just hold on a little bit. Okay, the question states, can this be used for disease modeling?
Yes, you can use it for anything that you want to put. That's why I say that you can even use it for if I have seen there's this particular library the guy that built this leprechaun library is more or less like a shiny a way of building complex shiny applications. I once saw him post on LinkedIn that built a full back end of an application using Plumber. Well, that means an application that is working with sign up, logging in. The front end was in JavaScript, the back end was in R. It even has a library that allows you to build that kind of application. I've forgotten the name of the library. So you can use it for anything that you want to trying to display. Or if it's disease model you're trying to model, you want to bring out the output or an image or things like you want to model a disease, you can use the Plumber. So it's very flexible.
Okay, thank you. So, Babatunde, you can go ahead with your question.
All right. Please, can you hear me?
Yes, I'm hearing.
Awesome. Wonderful presentation thus far. Thank you. Although I missed like the first part of the presentation, so I just want to get some clarity, to be precise. First, I want to understand Plumber actually use more like decorators for the input parameter. I just want to get, if yes, aside the get output, do we have something like post also that the API also can take data into the model as well? If that's also correct, are there other should I say other functions that one can use aside the get parameter? Then
Okay.
to another question is aside the, or do you want to take it one after the other? I talk faster, you know.
Just say it. Just say it. I'm hearing.
Okay. In part of serving the API, I know you mentioned Docker. I don't know if you have any experience hosting it locally. Let's say you have a virtual machine, say Ubuntu virtual machine that you are in control of, and it's already provisioned and you don't need Azure. Do you have any experience in trying to set up this API endpoint? That would be my second question. Lastly, I just want to be sure, you mentioned it earlier, just to confirm, you said it's not nice to be running the, what's it called? The model that one can save it as a pickle file and the likes of that. I just want to be sure, because I know pickle file is kind of like a cross-platform data serving way. Are there other form that one can store the data? And my last question, I can see you are returning a data frame, but I often know that um, an endpoint often return a JSON file. Is it deliberate or do one need to specify a list? What if one want to return like multiple data structure like a JSON file? Is this also permitted in R? Thank you very much.
Okay. Okay. Okay, let me take your first question. The parameters, right? So the inputs are parameters, are we? Oh.
Yes, please. I asked that it chooses decorator
It's
to
talking
take inputs,
about
right?
Okay, yes,
decorators.
yeah. I'm just trying to recall.
Maybe you can repeat your confirm.
Don't worry. I think I've already remembered the first question. Okay, so you can use, so I think it's already reflected. You said you missed the first part. So there was a point where I talked about this, the verbs, the methods for the REST API methods. So one thing with the guest, the post, most of the times, if you are not even careful, you can even use the interchangeably and still get what you are trying to do. But that's what we call best practice. So most of the times, when you're trying to update something, you're trying to put something, you use your post or maybe the put. When you're trying to get something, even though you are giving something, and you're trying to get something, because we are giving inputs to it from the function, but we are trying to what? Get something. So that's why I'm using the what? The get verb. More of the times, you'll not be getting anything in your MPI endpoint. You just want to send something to the server. You send something, that's where you can use what? Your post. More of the thing is that at times, if you are not even careful, you use both of them and it's still going to what? Give you your output. If you use post, you use the get, you can see that you still be getting what you're supposed to get. But more or less like a best practice of when you're trying to get something, you use the get verb. When you're trying to post something, you use the post verb. So for the second question, was the second question about me returning a data frame?
Yeah. You can, yes.
Okay.
I'm saying that JSON file is often like
Yeah,
API.
I don't know. Have you seen the output of what we returned?
Yeah, I saw it's a JSON like, but I'm
Aha.
surprised that how can a data frame just become JSON in the output?
So it's the way the plumber actually works. So that is where you can see I more or less like I mentioned something called serializing earlier on. So the API, REST API is supposed to return a JSON because you are using another application. So it's going to what? Serialize that particular data frame you have into the JSON. Now, if you have a data frame, you know you can represent a data frame as a JSON, right? But the thing
Knowing
is
that
that,
now.
yes, the thing is that the way it's going to be represented in the JSON is more or less like, okay, let's look at these outputs. Let me show something. I think, I think, did I have the output in one of these places? I think, okay, let me just do something here since these are not actually functioning. Have you heard or used MongoDB before?
I've not used it, but I know it as a concept. It's in the NoSQL kind of database, right?
Yes. So I think you know how the MongoDB works. You can see the actually JSON.
Okay.
Aha. So, but it's more or less like storing something like in JSON format. But if you look at it in a tabular way, you can see that you can actually represent it in a tabular way. Look at this now. These are the columns of our data. This is the DS, the Y, lower and the y-hat upper. If it's to return a whole data frame, for each row, you're going to be getting this. I don't know if you get what I'm saying. So let's say, for example, now you have a row number. You're going to be getting each of the, if you have 5 rows in your data frame, you're going to be getting 5 of this.
Okay, as a nested list, I think I get it.
Yes, as a nested list. You're going to get, if you have 10, you're going to be getting 10 of this. Now, if you want to just pick a particular value out of it, what you just do, you can just store it as a variable, which is a string, and return that particular string. Or you can create a list internally, your own list that defines what your response schema. That is how your response, you want your response to look like. You want okay, I'm expecting a response. I want my response to only show me y-hat. You should show me error. Then I can pick this y-hat, maybe by just filtering the data frame, because if you see earlier on now, I was using a data frame here, this forecast for dates, right? So I can actually just pick the y-hat value and store it as a variable and send it into a new list I'm going to create. Then that new list will not be defined how I want my response to be. And if you are just okay with you returning the whole filter data, once you return the data, it's going to come out in this particular JSON format. So you're not going to be expecting the way your data frame is going to look like. So I'm going to be returning this JSON format, just like you see it in this place earlier on. If I was to return because I was returning, my data frame is returning a data frame with just one row, because you see it, we filter for just a single date. But if I'm to return maybe multiple rows, you're going to be seeing multiple of this particular JSON. Yeah. So if you have 5 rows, you're going to be seeing 5. If you have 10, you'll be seeing 10 of it here. So I don't know if that part is clear.
Perfect, absolutely. Very, very clear. Thank you so much.
So the last one, I think I've.
Like I said, as I said, should I say it one after the other? Yeah. The last
Oh,
question is
no, don't
about
worry. It's just
serving
last.
serving the endpoint. I'm not saying, do you have
Okay, yes, the
experience in
Docker. Yes, the
locally
Docker,
hosting
Docker,
it?
Docker.
Yeah.
Okay. So, well, I don't think I don't, I've not deployed any Plumber using Docker, but I think the last deployment I did with using Plumber was that of Shiny. So, but the thing is that once you have it with Docker, the way you can deploy other applications, the challenge now using Docker with the app is trying to get your application into a Docker file. That's the challenge. But once you have that Docker file, anybody can even do it for you. Someone that is cloud. So because you already have everything that is already inside there, but there are some procedures one needs to follow to be able to deploy it inside to deploy it as a Docker file. So once you have it, you can be able to use it in maybe AWS or any other platform you're trying to use. But if you are interested in that, you can check. I think I showed you saw the documentation earlier on. That part of the documentation I shared for hosting with Docker. So you can go through that particular part and you can see how you can host your Shiny application with Docker. I think once you have with the Docker, then it's now late for you to know how to host it inside the platform of your choice that you're trying to host.
Thank you very much. Thank you so much.
Okay, is that all the questions?
No. We have one in the chat here. There's another one.
Okay.
From John. Concerning the data set, how do we add data to the original data set to help for more accurate prediction?
How do we?
How do we add data to the original data set to help for more accurate prediction? Maybe it's talking about future data, maybe because now you're using CSV, it's not it's not a data that is kind of being updated regularly. So this is like a start. Do you understand?
Yes, I understand. Okay. So
Yeah. So what I didn't mean that maybe you're getting it from an API, maybe the Bitcoin API, it will be updated. It's going to be like a real-time data. So how do
Okay.
we add it when the type data changes? Maybe some days were added later. How do we, I think that is it. So John, you're still online. Can you kind of confirm if we got your questions right? John, amazing what I hope I got that right. Are you still there? Okay.
Okay, maybe I will just explain for the benefit of others.
Okay, you responded. You said
Okay.
yes, please.
Okay. The thing is that, okay, just because
Oh,
it's an
okay.
example, what we just did here is something like, it's more or less like something you should build on. I don't know. Because most of the times in real life, nobody will be giving you a CSV file to be building model on. So you'll be having a database. You're going to be running it from there. Is from there you're going to even get your training and your training data that you run your data on. So they can even create a test made from that database if you're interested. So that's why earlier on when I was talking about the API, I was mentioning model decoupling. Models building is different from model serve. You have to separate the two of them. So once you train your data, and there is some now it's based on the organization that's actually using that particular model. Some people prefer to just deploy continuously from the data and just be upgrading the model immediately. Some prefer to break the models. We train this data, we deploy that model, we train this one, we see how it looks like, we deploy it. So that's what we call streaming. I think it's streaming models. Yes. There are some libraries that are meant for model streaming that they deploy continuously. I know of some for Python. I've even forgotten the name. I'm trying to recall. Though there's those models, it's just the same model that the random forest, the regression model, but they are meant to handle streaming data, a data that is just coming in. It's just coming in. So they're just like more or less like just running it. Is a streaming data. So you can still use those kind of models with it in such a way that maybe as the model is being retrained, you can have a particular file that is what's being updated. Then that file that is once it's updated is going to be updating the model weights, which new model will now be used on the go for that particular application they're trying to use it on. So the thing is that there are a lot of things that comes into model deployment is even more or less like another field on its own, because sometimes most of this data you can't even handle it with some of the tools that we use. You need to use more or less cloud to run some of these models to get faster outputs. So this is something that I don't know, maybe I can share some links with these resources that you can go through on it to understand more on this continuous deployment. I think that's it.
So do we have any other question before we round off finally? Okay. So, okay. So for all our members that have been joining us so far, we really appreciate your time here. It's been an interesting session. Okay, let me check this. Okay, so, well, okay, we're going to share the links and the resources, but please bear with us. We have limited support. We're going to edit the video. Definitely, we don't want to just push raw videos online. There might be some kind of things we might want to tidy up. So we're going to be able to do that before Monday. We should get everything from the Our Lady side and also the Abuja Our User Group. So please bear with us. We're going to share the code. We're going to share the data with you, or there'll be a report that will be shared. And we'll also post the video on our YouTube channels. So thank you everybody for joining us for today's session. We're looking forward to next month probably. And we're hoping that we'll be able to get our speaker down to join us. So we're just shuffle or agree on the timing because of the difference in time zone. So thank you, everybody, and we hope to see you next time. Thank you, Ridwan. I'm sorry, you've thought of us, but thank you so much. I really appreciate your time here, Ridwan. Thank you so much. And I
Thank you.
hope we're still together. We'll be together for as long as, inshallah. So thank you so much. I really appreciate your time.
Thank you.
Really calm and ways of teaching. You're really a good instructor. Thank you so much. Thank you.
Thank you very
And
much.
thank you once again, everybody. Thank you.
Yeah. Thank you.
So bye.
Bye-bye.